Endeavors. Stories powered by UNC Research. For her brother. Upon watching her brother grow up and struggle with cystic fibrosis, Rhianna Lee has dedicated her life to studying the disease. By Alyssa LaFaro. March 21st, 2023. When Rhianna Lee was 11 years old, she attended her first funeral. Her cousin Donald had passed away from complications caused by cystic fibrosis, CF. He was 23 years old. CF has always been a constant presence for Lee and her family. At the time of Donald's funeral in 2005, her cousin Michelle and 2-year-old brother Al both had the disease. But Donald's death forced the realization that CF could kill, and at a young age. I knew my brother had CF, but I didn't really know what that meant or how it would change his life until Donald died, she shares. It's a scary enough disease that once you've seen it, you want to do something about it. Michelle died in 2017 when she was 29 years old. She desperately needed a lung transplant, but she didn't weigh enough to qualify, a common problem for people with CF. Shortly after Michelle gained enough weight to be considered for a transplant, she slipped into a coma and contracted a bacterial infection that permanently removed her from the list. She died without even knowing that, though, Lee says. Cystic fibrosis is a genetic disease that causes a buildup of thick, sticky mucus in the lungs that triggers heavy coughing and creates a breeding ground for bacterial infection, which sends people with the disease to the hospital multiple times each year. In any given year, Al would go to the hospital about 6 times, each time for about 2 weeks, Lee shares. It impacts his ability to go to school, even have a job. From the mental health perspective, he was always sort of worried about his health. So was the rest of my family. Today, Lee is a PhD student in the Department of Cell Biology and Physiology at UNC Chapel Hill. She works on developing therapies for people with CF and creates cell lines to test therapies that can minimize symptoms for those with rare types of the disease. CF is caused by 2 mutations to a single gene that provides instructions for making a protein called the cystic fibrosis transmembrane conductance regulator, CFTR. This protein acts like a taxi for various fluids and salt, moving them in and out of cells that produce mucus, sweat, saliva, tears, and digestive enzymes. Salt, or chloride ions in this case, attracts water and thins mucus. A mutation to the CFTR gene can lead to a malfunctioned protein or no protein at all, causing mucus to accumulate in the body. While it takes just 2 mutations to cause CF, they show up in many forms. Over 2,000 different mutations are possible within the CFTR gene. It's like a slot machine, with 2 reels instead of 3. The lever gets pulled during conception, when both parents have 1 copy of the defective gene. They are considered carriers of the disease, but don't have it themselves. During fetal development, the reels stop, and 2 mutations occur. This is why CF diagnosis and treatment doesn't have a one-size-fits-all approach. More than 35,000 people in the U.S. have CF, and 90% have at least 1 copy of a mutation called F58del. So, most research focuses on strategies and therapies for helping people with that mutation. The remaining 10%, though, have different mutations that can be so rare only 10 people in the world might have them. Lee's brother has 2 different mutations, F58del and S492F. He's one of about 24 people globally who have the second. One thing we've learned over the years as a field is that one therapy doesn't fit all, Lee says. So, whenever you study a patient's own mutations in their own cells, you get the best results for finding a therapy just for them. In 2018, Lee collected a nasal swab from her brother so she could create a cell line to test medications. Early on, she couldn't find anything that worked, but in 2019, a breakthrough therapy for CF called Trikafta entered the market, and when she tested it on her brother's cells, it led to high levels of CFTR correction. The drug works by targeting the defective CFTR protein, helping it function more effectively. In 2020, Al became a viable candidate for the new drug. Within the first week, his lung function improved exponentially. Trikafta really is like a miracle drug. I remember during that time, between coughing out everything in my lungs, feeling like this weird energy in my chest. I was like, is this breathing? Al says with a laugh. It was such a surreal feeling. Give it a month or so, and I felt greater than I've ever been. Upon recent testing, Al discovered his lung function was at 80%. A shockingly normal level, he says, considering he's had moments when his lung function was as low as 30%. Additionally, he's had no major hospital stays since starting the medication. Before Trikafta, life expectancy for people with CF was about 39 years old, Lee says. Just with the approval of this one drug, life expectancy is now 49. So this new treatment added roughly 10 years to my brother's life. Battle of the Blues. In 2011, when Lee began looking at colleges for her undergraduate degree, she wanted to pursue biomedical engineering. At the time, no treatments addressed the underlying cause of CF, Lee recalls, but there was a vest that looked like a life jacket. You put it on, it inflates, and it pumps air in and out. It's called chest percussion therapy. It helps get out some of the mucus that's not clearing. Since creating biomedical devices seemed like the best way to make a difference for the field, Lee set her sights on Duke University, home to a well-regarded biomedical engineering program, and just 4 hours away from Lee's family home in Irmo, South Carolina. My sister was so determined to go to Duke that when my mom tried to convince her to have backup options, she'd just say, "Nope, I'm going to Duke," Al says, chuckling. And she did. 1 year into Lee's degree, a few new drugs for CF came onto the market, and she realized she needed to get into a basic science research lab to learn more about how the disease works. Devices will always treat symptoms, but medical research treats the root cause, she says. Her math professor connected her to scientists at the UNC Cystic Fibrosis Center. At the start of her sophomore year, she began taking the bus to Chapel Hill 3 days a week to work at the center. She spent the next 18 months designing cell cultures and constructing a robotic nebulizer to study the effects of aerosolized medicines on airway cells. After graduation, she became a full-time research technician at the center. In 2018, she enrolled in the PhD program within the UNC Chapel Hill Department of Cell Biology and Physiology. Today, on top of building cell lines to study rare forms of CF, Lee develops cell therapies for the disease. This involves delivering the patient's own stem cells to their lungs to correct the underlying defect. The goal is a one-time treatment that would work for all people with CF, regardless of their genotype. Lee has spent the last 2 years developing a new system for studying the airway. She dissects small pieces of lung tissue, places them on a gel foam sponge, and then soaks them in a liquid media. This keeps the tissue preserved for several weeks and allows for analysis that wasn't possible before. She uses the procedure to study viral infections, including SARS-CoV-2, and gene or cell therapies. Slated to graduate this May, Lee hopes to pursue a postdoctoral research position to continue studying CF. Her goal, though, is to become a full-time researcher in the UNC CF Center. It's sort of like an honor to know that Rhianna got into this very complex field and researching because I was sick, Al says. It's awesome knowing she'd go that distance and that me being sick has a purpose like that. Rhianna Lee is a PhD student in the Department of Cell Biology and Physiology within the UNC School of Medicine.